Okay, lesson 4 deals with application of vectors. So now I want to take the vectors that you were working with, the skills, and I want to show you some of the applications that can arise. So the goal is I can take my knowledge of vectors and solve problems requiring the need to determine a resultant. Okay? So 4 examples I'm going to go through. Third example, if you're comfortable with it, you can skip the third example, but the fourth one's fairly important, so don't get too far ahead. So, camper kayaks, 13 kilometers east, 40 degrees north. So, what I need to do here is I need to give myself a bit of a sketch here. And the camper kayaks, 13 kilometers east, 40 degrees north. So, 13 kilometers, 40 degrees. From our campsite, and then turn to travel 20 kilometers east, 80 degrees south. Now, because we don't have to do head to tail addition with algebra, I do everything, I draw all my vectors from the origin. Okay? So the next one is east, 80 degrees south. So it's going to be down here. I know that it's not exactly what she's doing, but because we're doing the algebraic method, we can just draw all our vectors with the tails at the origin. So there we go. You can name them however you want. I'm just going to call them U and V to make life easier. We want to know the camper's displacement. Well, her displacement, and I can use a D for displacement, is just going to be U plus V. So the U vector plus the V vector is going to give me my displacement vector. And you can use R here for resultant. That's fine by me. So we end up with, this one will have positive X, positive Y. This vector will be positive X, negative Y. So I know I will have 13 cos 40i plus 13 sine 40j. My V vector will be 20 cos 80i minus, because that Y component's negative, 20 sine 80j. I'll pause that again to get the X and Y components. So when we calculate our X and Y components, or I and J values, I get 16.9i minus 11.3j. The magnitude then of her displacement. So again, here we're asking for displacements of vector. How far is she from her starting point? It's not how far did she travel. If it was how far does she travel, then you would just add up the two distances, 13 and 20. But we want to know how far is she from her original campsite. So we end up with the 16.9 squared plus the 11.3 squared. And we'll take the square root of that. 0.5. And I get 20.3 kilometers. So 20.3 kilometers. So she traveled 33 kilometers, but she's only 20.3 away from where she started the day. Look at her direction here. So tan inverse 11.3 over the 16.9. So to get that, bracket 11.3 divided by 16.9. And we want to do inverse tan, 33.8. All right, so therefore, her displacement is the 20.3 kilometers. Direction, positive I, so she started heading east. 33.8 degrees. Negative Y component, so that means she was heading south. So if you wanted to find her and you were flying a plane, that is where you would have to fly. All right, moving along. Speaking of planes, the plane is flying 100 meters per second in that direction. The wind's blowing 20 meters per second from that direction. What's the plane's resulting velocity? So even though you set the accelerator or the throttle on the plane, doesn't necessarily mean that's what you're actually doing. I'm going to give myself a sketch of what's happening here. So that's north and east. So the plane is flying east 50 degrees north at 100 meters per second. The wind is blowing 20 meters per second from. So you got to be careful here. So this is where I would be facing. It's in my face if I'm looking in that direction. So if I'm looking west, 20 degrees south, so here, the wind is coming at my face. So the vector is actually over in this quadrant. All right, because it's blowing in your face. All right, so we know that the angle here was 20 because of the X pattern. We know that this angle is 20. Okay, so you need to be careful with the wind. Wind is always a tricky one, just the way it's worded. So the resulting velocity, again, you can use whichever variables you choose. It's like algebra. I guess I might as well use W for wind. That would make the most sense, wouldn't it? So the plane plus wind gives me my velocity. So U plus W is going to give me the velocity of the plane. So 100 cos 50I plus, because both are in the top right quadrant, 100 sine 50j. The other one's going to be 20 cos 20I plus 20 sine 20j. Then we'll calculate our x and y components. So I end up with 83I plus 83j. So the magnitude of the velocity then. So how fast is our plane actually traveling? So when they set the throttle, they set it at 100 meters per second. If we check that, 83 squared times 2 and square root of it, 117. So the plane, thanks to the wind, actually gains 7 meters per second. So it's like a tailwind, or it is a tailwind. And tan inverse is going to be 83 over 83, which is 45 degrees. So therefore, the velocity of the plane is 117 meters per second. Both are positive, so it's going to be heading east, 45 degrees north. Okay, I'm going to leave example 3. You can try it yourself. There's really nothing different on this one. It's the last one. Example 4 is the one that I really want to tackle here. And this will be the final example then. And the difference here is you're going to see it right away. Okay, so a plane wants to travel at 200 kilometers an hour north, 30 degrees west. So north, 30 degrees west. So there's two important things that are in this question that I can't stress enough. So 200, and it's going north, 30 degrees west. If there's a wind blowing from west, 45 south. So again, that means that the wind is coming in your face. If you're standing there, it's hitting your face there, so it's actually over here. And it was at 45, or how fast was it? 50, sorry. The angle was 45 there, so it's 45 up here. One of the major problems, and I can't stress this enough, so please make a note, to use algebraic vectors, and if you look back, every question we've done so far is true to this. To use algebraic vectors, the angle must be with the x-axis. The angle, oops, hitting everything now. The angle must be with the x-axis. All right, that's the only way our algebraic formula and all the formulas we use works. So this angle is not good for us. We don't want this angle. It's this angle we want. So please be aware when you're going through the questions, the angle must always be with the x-axis all the time. So that was one of the tricks. The other one is the plane wants to travel. That's actually the resultant. So we know that the resultant is equal to the plane speed plus wind. But we actually know what the resultant is. This is the resultant. This is where the pilot wants to go. We want to know what settings the plane should travel. The beautiful thing about algebraic vectors is that we can treat it like algebra. So we can just subtract the wind vector, which means that if you take the resultant, subtract wind, you end up with the original plane settings. It's just that's nice, okay? Vectors follow every algebraic rule we have ever taught you in math courses, okay? So, that being said, I'm just going to shrink this a little bit to give me some room. Okay, so that means that I'm going to follow that formula. Resultant minus wind is going to give me the plane vector, or the vector where the plane should travel. So going through that, 200 cos 60 with our new angle, and it's negative because it's in that quadrant. The x component would be negative, plus 200 sine 60 j. Wind, both components will be positive, so 50 cos 45 I plus 50 sine 45 j. Now we're just going to go through and we punch it through the calculator. So once you do the calculations, we get that the plane should travel in that direction or that particular vector. So we want to break it down so that the pilot knows exactly the numbers. So 135 squared plus 138 squared. So we find that the pilot, in order to travel in that direction and that distance, plus 138 squared equals exponent 0.5. So 193. So they have to set the throttle at 193 kilometers per hour. And the angle in which you must travel, or the direction I should say, 138 over 135. I'm using the calculator. 138, 135, inverse tan. It's 45.6, so 45.6 degrees. So therefore, the pilot should set the plane at 193 kilometers an hour, and it should be heading west 45.6 degrees north. So there we go. We now know the plane's direction and ground velocity or throttle velocity. So there's two things to remember here. Please, when you go through, A, the angle has to be with the x-axis whenever you want to use vectors. So that must be true. Secondly, you can add and subtract vectors, same as you do with any other algebraic equation. So you can rearrange algebraic equations, or vector equations, to suit what you need to do. So you can do resultant minus wind. All right. If you have any questions with the word problems, let me know, and we'll try to straighten out what the issue is.